Good afternoon, everyone. So here I have the model of the pulley. So as you can see at the back here, there is a handle. So this handle can be rotated clockwise and counterclockwise. So when you rotate the handle counterclockwise, it goes down. When you rotate it clockwise, it goes up. Okay, that's the basic. So we are doing a concept on kinematics. So under kinematics, you learn two things. One would be changes in motion. So changes in motion, let me start off simple. So when I turn the handle around, you can see that the components are moving in a circular manner. This circular manner means that we are applying rotational motions. Rotational motion. From here, the motion will be transferred onto this rope. Now this rope, I just like you to focus on any point, maybe this point or this point. Now this rope, it can only go two ways. It can go to the left, or it can go to the right. So maybe your right and my left is different, but that's okay. So from here, it will change back into rotational motion. From rotational motion, it will transfer into the tension, the rope that's holding the platform together, changing it back into linear motion. Now, why is it linear motion? Because the platform itself can only move in two different ways, which is down and up. It's very simple. That's the first thing you learn about kinematics, which is changes in motion. Now, the second thing you learn in kinematics is uniform motion. So, this is your starting point of movement. I'm gonna move it at a steady rate. 1, 2, 3. When you spin the handle at a steady rate, the platform's velocity is constant. When velocity is constant, acceleration will be 0. Now bear in mind, acceleration is not 0 at all times. There are two specific phases where acceleration value are non-zero. One is right now. The platform is not moving, it is stationary. What if I move the platform and it moves? Initial velocity was 0, but then the final velocity is a value of positive number. This means that your platform experiences positive acceleration. The second phase would be while it is moving. What if I suddenly stop? I don't even touch the handle. So it was moving and now its initial velocity was non-zero. It's a positive value and final velocity is 0. This means that your platform, this platform over here, has negative acceleration. Or in other words, we call it deceleration. Now I will go over two more physics concepts that is integrated onto this pulley system itself. First being forces and torque. When you apply force on this handle, you are applying a kind of force we call torque. The formula for torque is T equals F times R. F being force and R being radius. Now just focus on the word radius real quick. When you think of radius, you think of a circle. Exactly where it comes in. When you are applying a rotational motion, you're applying force. And that is where forces and torque comes into play. Now the last physics concept is principle of conservation of energy. When you are applying force from your thumb into this handle, your thumb over here is applying mechanical energy. Mechanical energy lies into the components. As soon as the components move, you have kinetic energy. Because why? Everything that moves must have kinetic energy. Because what? You can see that it's moving. Components are moving. When it moves, kinetic energy all the way to here. Now, final destination will be here. From kinetic energy, it is transferred onto what? It's transferred onto the potential energy. The formula for potential energy is PE equals mgh, mass times gravitational acceleration times height. But bear in mind, G is not accounted in calculation. Why? Because we have tension. The platform is being held by this backstrap. Now that eliminates G. When do we apply G? We apply G when an object is free falling. For example, now this object, when it falls down, it has G. G value being a constant, 9.81 meter per second squared. Now, it is important to bear in mind that this model is not perfectly accurate. So if you make the calculations on paper, it might not give you the same number of calculations or answers as the real model. Why does this happen? Mainly because it happens because of two factors. One being internal component friction. All the components have friction between each other. So your energy from mechanical all the way to kinetic, some of the energy will be lost due to friction. So from mechanical energy, some will go to kinetic, and another will transfer to friction and lose as heat energy. Now, the second issue is this rope over here. It's made out of rubber band. Now, as we all know, rubber band has a tendency to be flexible. It is flexible. That's what we all know. When an object is flexible, it has APE, which stands for elastic potential energy. Now, the formula for elastic potential energy is 1 over 2 kx squared, which k stands for spring constant, x is for length, or 1 over 2 mx. M being force, x equals the difference in length. So, these are the things that you have to look out for while you are doing calculations. And the benefits of this model, it is safe to use. Now, how do we know that it is safe to use? Let's put a finger anywhere you want and just rotate the handle. Rotate the handle where you want. You can see that although your finger might get stuck here and there, it does not produce a real harm to the user playing. That is one benefit of mechanical components. They operate based on stability and tension, and not based on, and they don't act just like electric. If I put a motor here and I put a battery here, we can risk electrocution. What if the wires were corroding? So over time, the risk of it happening would increase. And the benefit of this model is it's easy to use. It's easy for multiple demonstrations. Improvements are we need a stronger frame, and you can see that the rope here is not perfectly in the middle. So weight distribution is not really 100%. So those are the physics concept that we have in our physics handle, in our pulley handle. Thank you.